Okay, so I'm going to help you understand how to work out section 7.1. I'm going to do a few examples of each section so that you understand exactly what is being asked you to do. So let's click this first one. So adding vectors commutatively is just going to be the first section, a guided practice one where it will basically hold your hand and walk you through on how to add vectors. So you are given 4 vectors. Each vector has an x and y component. In other words, it has the horizontal and the vertical component that it's going to cover. So the first thing you're going to do is you are going to line them up with the x's and the y's lined up accordingly so that you have your common terms being combined. -1 plus 4 is a 3. 3 plus 1 is a 4. 4 plus 3 is a 7. 5 plus 1 is a 6. 6 plus 3 is a 9. 9 plus a -2 is a 7. So I'm going to check my work, and if it works out, it will allow me to go on to the next section. So notice that you have 4 vectors that are graphed based on what was given to you. So -1, 5, if I stand here at 0, 0 at standard position vector, and I go -1 to the left 1, up 5, up 5. This is my terminal point of vector A, so I would have drawn from 0, 0 to vector A, -1, 5. I'm going to do it one more time for vector 4, 1. Start at 0, 0. I go to the right 4. I go up 1. This would be my terminal point where this arrow is. So I'm going to draw a vector from 0, 0 to 4, 1, and so forth. So they graphed for us already. You don't have to do that. This is already graphed. It's placed for you. So they want us to add the 4 vectors graphically in any order, tail to tip. So what does that mean? So I'm just going to pick one of these vectors to stay stagnant. It's going to be my beginning vector. It doesn't matter which vector it is. I'm going to choose vector 8 to be my beginning vector. So that means these 3 others I'm going to translate. It needs to be tail to tip. What does that mean? So I'm going to move C first. Why? Doesn't matter. Any order. I need to connect it to my stagnant vector, which in this case is my A. So there's my tail to tip combination. So you see, in other words, I can't do this. That is unacceptable. Okay, that's not a tail tip combination. When I'm adding vectors tail to tip, I'm going to move another one right here. I'm going to move another one right here, and you're going to see what happens. Okay, it would automatically draw the resultant. This is your resultant vector of when your vectors are all added. Notice your resultant vector should have this answer. What do I mean by that? Well, does the orange vector go to the right 7 and up 7? Yes, it does. That's the same answer you did algebraically. And then they say, hey, by the way, do you know that if you add vectors in a different order, you'll end up with the same answer? So they just want to show us that. Let me choose D vector to be the stagnant vector. So I'm going to move these instead. Okay. Again, any order. Notice what's going to happen. Resultant's going to be drawn. Notice my resultant is the same as above. I'm still going to the right 7, up 7. The route was completely different, but my resultant is still the same. And then I'm done. So that's the first section, okay? What you're going to do in this section here is that you're just going to do it by hand. You will do it yourself. So add my vectors. So again, the vectors are graphed for you. I'm just going to move this one over here or this one over here. It doesn't matter which one you choose to be your stagnant vector, okay? Oh, it doesn't like me doing that, okay? I think because I moved this one already. So I've done that. Once I've dragged it, you are going to notice that this here you have to visualize as being your resultant vector. So imagine if I took an orange line of vector and I drew it from 0, 0 to right here. So what would be the answer? Well, I would have gone to the right 2 and I would have gone down 4. So to the right 2 and down 4. And I'm done. And we can verify that at -2 plus 4, it's a 2. -2 plus -2 is a -4. So algebraically, I can verify if my answer is correct. I'm going to do another one more time. 5, 1, and 3, 6. I can move either one, tail to tip. Where is my resultant? 0, 0 to right here, which is what? To the right 7, to the right 8, up 7. So 8, 7 is my answer. You can check it algebraically, and that's all you do. Let's go back. Adding vectors numerically, well, you know how to do that. That's just adding by hand. 5 plus -3, -2, -7 plus 7, 0. So you're still doing what you were doing in the previous section, except whoops, what did I do here? Oh, no. Oh, that's a +2. There you go. You're still doing like what you're doing in the previous section, but this one is specifically having you do it by hand. All right, multiplying vectors. So graphically and numerically. So what does this mean? I'm being given vector -6, 6. So here's some vector -6, 6, and they're telling me, hey, I know you're given the vector, but I want you to multiply that vector, v, by 1.5. Well, when you multiply something, that means your vector is growing in length, okay? So this vector is one vector, but I need it to grow 1.5 more, okay? So 1 plus a half more. So I'm going to drag, if it will allow me. Why is it not doing it? I'm trying to grab the tip, but it's not doing it. Let me back out and then go back in. Sometimes you have to do that, I've noticed. Okay, let's see if it will work this time. Oh, it is not letting me do it. Okay, I'm not sure why. Multiply graphically by stretching the vector by its tip. Okay, this is supposed to, I don't know what's happening. Oh, there it is. It just did it. Okay, there we go. So there is 1 and then a half. And what is that answer? The answer is -5, 9. No, -9, 9. -9, 9. And I'm trying to see if I can pull up, I can't pull up a calculator. But what I was going to tell you, if you multiply 1.5 times -6 and you multiply 1.5 times +6, you will get -99. So if you want to do it algebraically to check your work, you can do that as well. Okay, let's see if the next problem, let me do another problem just in case it'll work better. So what does this mean? Okay, so I'm being given vector 1, 1. So this is my vector. That's one vector, okay? When it's written like this, it's one vector. And so now they're saying, hey, I want you to draw 2 vectors, but this time I need you to flip it because that negative means to flip it. So what I'm going to do is I'm going to take this one vector and I'm going to flip it, okay? But I know I needed 2. So let me extend it doubly longer, and then I'm going to let it go. So there's my -2. And still, if I multiplied -2 times 1 and 1, what did I end up with? -2, -2. So here we go. -2 and -2. Okay. So that's how you do that graphically. Scalar, just like we've been doing, take this number, multiply it by both those numbers. So this will end up 2 times 2.5. I think that would be a 5 if I'm not mistaken. That number is the same. So if you distribute that 2.5, yep. Okay, so 2.5 times 2, 2.5 times 2, and you get 5. So that's just straightforward. And subtracting vectors, same thing as adding, except you're subtracting. Watch your order. Here's where you need to really, really watch your order, because sometimes they'll say u minus v and sometimes they'll say v minus u. So please be careful with that. So u minus v. So I'm going to take my u vector, x component, 8 minus 4. So 8 minus 4 would give me 4. I'm going to do the y values. 1 minus negative 4. Well, 1 minus negative 4 is 1 plus 4. So I'm going to put a 5. I'm going to try that out. It gave me the go ahead. And then I'm going to do my graphing. I need to find the difference of u minus v. So I need my u vector. So here's my u vector. It's going to stay stagnant. Stagnant means not moving. So I'm not going to touch it because I just needed one u vector. But then it's saying, hey, I want you to combine tail to tip a negative v vector. Well, negative means that you see this v vector right here. I'm going to press this to flip it to negate the vector because I needed a negative vector. And now I need to combine them tail to tip. So I'm going to drag tail to tip. And then once I've done that, I need to write the answer. So I need to grab from here, drag the resultant, always from 0, 0. Resultant is always from position vector form, 0, 0 to your terminating point. And so there, I'm done. Then they're saying, hey, notice that these two vectors were not moved like this one. But if you want, you can still draw a vector from beginning to end here that will match the same one as this. So if you graph from left to right here on this, do the same thing, left to right here. So notice they're the same length. And I'm going to submit my answer. Oh, wait a minute. I wanted to show you here. Notice the answer you had of 4, 5. Again, 1, 2, 3, 4. 1, 2, 3, 4, 5. Same thing over here. Starting from here, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay? Let's do it one more again. Okay, one more problem. U minus v. So negative 4 minus 6, negative 10. 6 minus 6, 0. I got the go. U minus v, leave the u stagnant because I only needed a positive u, don't need to negate it. My v needs to be negated, so I'm going to negate it. I'm going to do tail to tip. Don't do this. That doesn't work. Tail to tip. I'm going to let it go. And based on my tail to tip, from here to here, it did go negative 10, 0, just like I said it would. And so what do? I do negative 10, 0 from here to here to prove that it works as well without having to translate the vectors. And I submit. And you're done. Last but not least, both of these are the same. I'll just do the graphical one just to walk you through it. This last one, they're telling you you want one V. So I'm going to leave this V stagnant, not moving. And then I'm going to, I think I need to click it. Yeah. So I'm going to click that V. And then I need to add 2 U's. So I'm going to do 1 U here. Whoops. Click and drag. Click and drag. Tail to tip. I need another U. Click and drag. And once I've done that, I think nope, don't do what I just did. I thought we were having to draw a resultant, but we don't. Come over here, imagine your resultant. So my resultant would be from here to here, which means I would have gone to the right 7 up to, right 7 up to. And you're done. One more again, 2 V's. So I got 1 V, and then I need to grab another. There's my 2 V's, and then I need to negate a U. So here's my U right here. It says negate the U, so I'm going to negate it, and then I'm going to drag it, because if I just click it, you see what's going to happen? Connect the tail to the new vector. So my most recent vector was this one, so I need to take this negative U, bring it up here, and connect it. And I'm done because there are my 2 V's, my negative U. I've added all the vectors together, this will be my resultant, which is -2 up 5. -2 up 5. And I believe this, so that's it for that section. This last section, you're just doing it all by hand. Okay, so you're doing a u plus 3 times v. So you're going to take this u and you're going to add it to multiple of 3's. So if I multiply this by 3, this would be a 9, and this is going to be a 6. So if I add it, 1 plus 9 will give me a 10. And this would be 2 plus, this would become a 6. 2 plus 6 would be an 8. So that's how you do that one. Okay, so I hope this helps you understand how to do section 7.1 of Welcome to Vectorland. Let me know if you have any questions. Just reach out.